also beta algebras. This is my final milestone for independent research 2 with Keenan and Depaul. Basically, where I was working on this project called Luminaire. I think I forgot the title here. It still says the name of the last project. But basically, what we're working is on creating end-to-end, doing an inverse stenographic projection out from a TGA and converting it into a printable 3D file. What I'm going to do is I'm going to run through the application first and show that we can get all the way to the output and get it ready to printer. I'm going to go showing the steps and the extra tools that we use. I'm just going to do it for one of the files, and then I'm just going to come open it back again and show another files. After that, I'll show my diagram of classes really quickly, and that'll be it. So this is just start screen. It's a little thing that moves, just so we know it's alive. Basically here what happened is it's the rendered projection for this grid. For some reason I'm getting compression and they're coming out really close. The projection is working, they're coming out really close. I didn't have this compression before in the middle class. I don't know what happened. So the blue square is just the light position. This is the rendering itself, and if this was right here instead of where it is, it would basically be matching. It's basically from that light to that angle, it's making this shadow. So what you're seeing here is just the parts that we need to remove from the sphere to be able to cast this exact shadow that's on that square. If we change it, for example, we would triangle, you get that little triangle, and if you go to star, you get the star. It's not completely intuitive the way it is right now. It'd probably be better if I had the light on the other side to show, but the problem is, for some reason, I'm getting compression and I'm getting that light inverted. So I'm getting a reflection instead of the actual light when I do my math. I run the math on paper and check that out, and I don't know why it happened. But anyways, so you can do square, you can do triangle, and you can do star. So let's just convert it to open. So you can come here, say we did square, you can come here, light test, and check it out, and you can see the reflections. Oh shit. But let's say, just pick square, let's start, and let's go to OpenSCAD. When we click here, what it does, it creates a file for OpenSCAD. If I go here where my project is and look for star.scad, which is the file format, we basically generated this file. And this is the output that we get. It's human readable. I made it so it's actually readable. And it's just basically the position of every single one of those squares that we need to do. What I'm doing is I have a center point in the middle of the sphere, and then I know where the square is, and I just subtract that from the sphere. I also hold down the sphere, so it actually makes sense if we work to put a light in it. So right now I'm compiling and rendering, and here we can see the sphere. It's really small, so I'm gonna go zoom in. It's really small because it's just a unity sphere. If you want it bigger, you can just use scale. It's not a big deal. Just give me 1 second while I zoom in. I think it's my machine time problem rendering. And we lost it. Now we're gonna have to open this again 1 second. So I think my machine's having a little bit of problems rendering at the same time as recording. So I'm just rendering it. Getting closer. I might be using too many. Anyway, here we can see the projection on top. That was the projection we did. It assumes that it basically assumes that the light's on top. And you can see how it's like gridded the same way as the squares. If we change the shape, we'll get a different one here on top of the ball, on top of the sphere. I'm suffering compression. This should be spread out. You see how it arcs here? This should be spread out across the side of the sphere, and it was working better on also one, and I did something and I can never figure out. I tried going back, but I can never figure out where it's getting compressed. But yeah, so basically these are just all the squares. that we had. And if I take it, if I go back to like the normal process, right now we're in a normal printing process. So I can go and say, so we hit preview, we need to render. I can go and create the actual mesh. Just give it a second, it's taking, it's gonna take a little bit, just because my computer's slow. It's a pretty big mesh. We have around 1,000 voxels in here. I was using a 60 by 60 by 60 voxel sphere, so there's a lot of voxels on the result. So that's why it's kind of taking a little bit to compile. But I'm gonna open the other program while it compiles, just so I'm ready, so I can show how we can render it and get it ready for printing. So this is Cura. It's a slicer. That's the new version. Okay. So let's just give this a second. I just want to show that it goes all the way to the process. So here you can see it finished rendering. It took about 6-7 minutes. The interesting thing is they have edges. So this technique has a problem because we're just basically poking holes through a ball. It ends up with a lot of half edges and with a lot of edges, which is not great because it honestly makes the time that it takes to render like a lot. So I'm gonna go and export it as an STL. We can do that here. I'm gonna call it sphere STL, and it's gonna put it on the desktop. Cool. So now what I'm gonna do is I'm gonna load Cura. So that program that we're using, basically it's a high-level language, OpenSCAD, that lets us take what we got from our thing and lets us make it into an STL. The STL now we need to make it into G-code, which is what my printer actually takes. So Cura is a program that takes STLs, and you can model and tell the size, and then you can like basically tell it to print. So I'm gonna go look for it here, sphere.stl. Here we go. And we were using the unitary, so it was really small. You can see on top the pattern that we wanted. So if we try to print that big, it tells us that's 0 minutes, but that's not really useful. You actually want it to be like a real size. So we can come here, and we're gonna do a uniform scale. Probably something, I don't know, around 12 times the size, maybe 14. You're gonna see here, next to the mouse, it's gonna take us, okay, now this is gonna take 27 minutes to print. We can take here and take a better look at the pattern. That's what we're gonna be printing and what's gonna make our light basically happen. So this is a hollow sphere. But yeah, you can see there the pattern. Because jello with jello, you can't really see much. But anyways, you can see that if we go out now, so it's 27 minutes, 190 meters of materials. And if we go here, we can actually see the G-code that's actually going to get it started, and the end G-code. So we can say save it. It's going to put it on desktop again, so I can go open it. Okay, here it is. I'm going to open it with Notepad. So you see what it is? So it's basically kind of like similar to assembly. It's basically just instructions that tell things what to do. So basically, what are your metrics? And then you go to the printer and you tell it on the bed, go here, put a little bit of material, And this is the amount of layers that you have. So the amount of layers, it's really easy to know. Like, for example, in this printer that I use, you multiply it by 4 seconds and you can know the amount of time it's going to take. So 153 by 4 is about the time we're going to take to do it. And this other instructions, like basically like, do we start with the fan out, do we start with the fan on, and that kind of stuff. And this is basically the output. This is what we got all the way from Luminaire. So now I'm going to go back to Visual Studio. And I'm actually gonna open the class diagram really quickly. So this is what we have here. This was the code that I took. We got a lot of reuse from last time. So all the command structure basically was from last project from Paleta UI. I used it from the first semester independent research. Over here, all the scenes are new, but the scene handling mechanism is also from Paleta UI. So I'm basically using the UI interface for 2D on top of 3D. And then basically this is the algorithm. So we have the cube plane, the cube sphere. The graphic object is just from Azul. So the cube plane and the cube sphere, it's basically based on the voxel based object that's down here. And what it does is that it like basically uses a lot of small boxes, the boxes that we're originally using Azul, to actually make shapes. And I use this because it lets me scale down and up based on resolution. Ideally, if I was making this and working further in this project, I will go in there and try to take this, like simplify the result. Right now we just use the dots and throw out the result, but ideally you can go and like touch each one, you know, and like move it. So if you have two close, just make it into one, and basically make all this faster. Like we have a lot of overlaps in terms of when we remove items from the sphere. So end to end, I think this research project was pretty interesting, and I learned a lot in terms of how to do projections and like how to get things from a 3D environment in OpenGL to like actual tools, like CAD tools. I didn't know anything when I started, so I had to do a lot of reading and just go to a forum. So you look at the references. I probably have 8-9 times the reference I had before. I think this has a lot less polish than my last project. Like honestly, I feel like I could work on this for 6 more months before I could actually have a really good demo to show like if it was going to be a solid project. But last but not least, let me go into the inverse calculator. So this is basically what does the projection. And it's just this method, calculate, takes a vector. Basically the way it happens is that you just take a vector, you take the x and the y. We're always assuming that so this formula I have down here is basically simplified, assuming that z, it's -1. So we're always using c in the plane of -1. Basically that means if you have a unity sphere, it's below it. And yeah, so basically this is what you do. This is what the inverse stenographic projection looks like. Once you bring that back, that just like puts it into, you just render it using the position from here into a cube to use the center of a voxel basically. Yeah, so the cube sphere, so this was my voxel sphere that I used to render. I stopped rendering because it was like 60 by 60 by 60, so it took forever. It added a lot of vertex and faces. So basically I just ended up rendering the part that we removed because it's really what we care and what we needed to look at. Somewhere here there's compression happening. Can't really tell where it is. Assuming it's probably here under the resolution maybe. So I need to like, I was working with it and I couldn't figure out. I looked at this, but this seems correct, so I don't know. Anyways, this is for Luminaire. This was my last project. Hopefully you liked it, and hopefully people enjoy it and have some questions that we can talk about.